Hello dear students of class 12 science, hope you are doing well. So in this video I am going to teach you packing efficiency. Now packing efficiency in simple cubic unit cell, body centered cubic unit cell and face centered cubic unit cell. So we are going to calculate. Now first of all, what is meant by packing efficiency? Now when we draw a crystal, now in a crystal we arrange atoms, we arrange ions, but the whole space is not occupied by the atoms. There are some empty spaces left behind. So when we say packing efficiency, it means the percentage or the amount or the volume which is occupied by the atoms in the unit cell or in the cube. So to start with, simple cubic unit cell. Packing efficiency formula is, in the numerator is the volume occupied by the atom or atoms. Like when you arrange the atoms in a unit cell, so the volume occupied by the atoms you'll write in the numerator. In denominator you'll write the volume of the unit cell. And we are calculating out of 100, that is percentage, so we'll multiply this by 100. Now the atoms which we arrange in a cube, that is cubic unit cell, are spheres. So we know the volume of a sphere is equal to 4 by 3 pi r cube. So the volume of an atom is 4 by 3 pi r cube. Now when we check simple cubic unit cell, the total number of atoms we have calculated in the last video, the total number of atoms in simple cubic unit cell is 1. So the total volume occupied by the atom is equal to 1 multiplied by 4 by 3 pi r cube. If the total number of atoms is 4, it will be 4 multiplied by 4 by 3 pi r cube. If the total number of atoms is 2, it will be 2 multiplied by 4 by 3 pi r cube. Now volume of the unit cell. If we consider a cube, since we are studying cubic unit cell, so in a cube, length, breadth and height all are equal, that is A equal to B equal to C. So let us take it as A. So if the length of a side in cube is equal to A, the volume of the cube is equal to A multiplied by A multiplied by A. That means length is equal to breadth is equal to height. So the volume will be A cube. So the volume of the unit cell is A cube and is multiplied by 100. Now, in order to calculate the packing efficiency, you need to know the relation between A, which is known as edge length. A is known as edge length, EDGE, edge length. Edge length and the radius of the atom. Now, in case of simple cubic unit cell, the atoms are present at the corners. So this is one atom for this corner. For this corner, so this is the atom. So if this is the radius of an atom, R, this is the radius of an atom, R, so A is equal to R plus R. That means A will be equal to 2R. So in place of A, we can write 2R. So it's 4 by 3 pi r cube, A 2R whole cube multiplied by 100. So this will be 4 by 3, 2r cube, 8r cube, pi value is 3.142 r cube multiplied by 100. So r cube cancel. Now if you simplify this part, you'll get 52.4%. That means the packing efficiency of simple cubic unit cell is 52.4%. Then what is the empty space? The empty space is 100 minus 52.4%. Next, let us see for body-centered cubic unit cell. Now, in case of body-centered cubic unit cell, the total number of atoms is equal to 2. So 2 multiplied by, we already know the volume of an atom is 4 by 3 pi r cube. Volume of the unit cell a cube, and is multiplied by 100. Now, in case of body-centered cubic unit cell, the relation between edge length, that means side of a cube, and the radius of the atom is A equal to 4r by root 3. So this is a relation between edge length and the radius of an atom. So it will be 2 multiplied by 4, 8 by 3 pi r cube. In place of A, we'll use 4r by root 3 whole cube multiplied by 100. So this we can write 8 by 3 multiplied by 64 r cube root 3 whole cube. We can write 3 root 3. Pi is 3.142 multiplied by r cube multiplied by 100. So r cube cancel. If you simplify, you'll get 68%. So the packing efficiency of body-centered cubic unit cell is 68%. In case of simple cubic, is 52.4. That means the packing is more efficient in case of body-centered cubic unit cell compared to simple cubic unit cell, because we have less empty space here if you compare with simple cubic unit cell. Next, let us calculate for face-centered cubic unit cell. So in case of face-centered cubic unit cell, we'll use the same formula. Packing efficiency is equal to volume occupied by the atom or atoms by volume of the unit cell, and is multiplied by 100. Now in case of face-centered cubic unit cell, we have already calculated the total number of atoms is 4. So now the volume occupied by the atom is equal to 4 multiplied by the volume of an atom, which we know is 4 by 3 pi r cube. Volume of the unit cell is a cube. Now in case of face-centered cubic unit cell, the relation between the edge length, that is A, and radius of the atom is 4r by root 2. So in place of A, we'll use 4r by root 2. So it will be 16 by 3 pi r cube by 4r by root 2 whole cube multiplied by 100. So this is equal to 16, 3 multiplied by 64 r cube by 2 root 2, pi value is 3.142 r cube multiplied by 100. So if you simplify this, you'll get 74%. That means the packing efficiency in face-centered cubic unit cell is 74%. Now if you compare simple cubic unit cell, body-centered cubic unit cell, and face-centered cubic unit cell, you'll find the maximum efficiency is found in face-centered cubic unit cell because the packing efficiency is 74%, which is more than the packing efficiency of body-centered cubic unit cell and simple cubic unit cell. That means we'll have lesser empty space in case of face-centered cubic unit cell if you compare with body-centered cubic unit cell and simple cubic unit cell. Next, we'll study the packing in crystal lattice. So packing in crystal lattice, we have to study in 1 dimension, 2 dimension, and 3 dimension. So we'll start with 1 dimensional packing. In 1 dimensional crystal lattice packing, the atoms or the spheres, you can say, are arranged along one axis. Say this X, Y, and Z. The spheres or the atoms are arranged only along x-axis. That means there will be one row like this. This is 1 dimensional packing. Now you'll be asked the coordination number of this packing. Coordination number is simply the number of atoms which surrounds an atom in the center. Like you take any atom from the middle, like let us take this atom. Now this atom is in direct contact with 1, 2, only 2 atoms. Is it in direct contact with this atom? No. Is it in direct contact with this atom? No. This atom is in direct contact with only 2 atoms. So the coordination number of this 1 dimensional packing is equal to 2. For 2 dimensional and 3 dimensional packing, we'll study in the next video. Thank you.